Hi everyone. Good morning. I just feel motivated to talk about data and profiling because it is a very important step in the data analysis process. And I've realized that for most people, especially young professionals, when they are given a project to probably answer a business question, maybe using a dashboard or something, they are so focused on just getting the visuals. They just want that beautiful dashboard to play around and see how it interacts. Truly, that is the end result, right? That is what you want. That is what you want to maybe share with the stakeholders or your manager or whoever requested for that analysis. But there is something very very important before you even think of the visuals. That beautiful artifacts that you want to show your to like show the stakeholders. And that is my motivation for today. I just want to talk about data and profiling. This is also in accordance or in respect to the 22 days data analysis challenge that is currently going on. So to the active members that are doing it, I think this will you probably benefit from this the most. But for the others as well, if you're just listening to learn, I believe also is going to help you if you are doing a personal project. Now, when we talk about data, basically there are two major data types. Okay, there might be so many but basically there are just two, and the two data types are, it's either something is numerical or we're talking about a text. Okay, it's either numerical or text. And for the numerical data type, okay, you can further split it into maybe it's, let's say it's an integer, it's a decimal number, it's a float number, all those kind of things. For the text, yeah, it could be categorical variable, it could be like really really a text like you passing on a message, right? But let's just focus on these two measure data types. And this is very important because when you have a data set, you know a data set is just made up of columns, and each of those columns are made up of data types. And when you have your data sets, it's very important you understand what is the data type of each column, because that data type is going to help you to understand, just to know, have a feeling of the data set. And this is also important when you receive a data set, you just don't have to rush into looking at what are the possibilities I can do for it, what the kind of visuals already. Slow down, start by just understanding the data, right? So try to listen to the data. Just understanding the data, that means even like profiling the data, will help you to even answer some of the business questions before even coming up with visuals. Or it can help you identify if the data set you have can even answer the business question. For example, assume that your manager is asking you to analyze profit, and there is no data about sales or expenses, then you cannot analyze profit, right? So that is why it's important to take your time and really understand the data. So listen. Start by listening. Don't start by trying to force or try to already think of what are the possibilities I can do with this data set. So the first step is always listening to the data set. And that listening means just like profiling. So when it comes to the numerical data types, it is important to understand that what are the kind of things I can do with a numerical data set or a numerical data type. So, I said basically a data set is made up of columns, right, or variables. And, a variable can either be a numerical variable or a text variable, or we could call it a categorical variable or whatsoever. Now, when we have a numerical variable, what are the kind of things you should look at when you have a numerical variable? If I have a numerical variable, for example, let's say age, okay? Example, this is for numerical. Example for numerical variable, we have age, okay? And for the age, we do have, let's say, 22, 25, 16. 30 and 45. Now let's assume this is one of the variables in your data set, and you have any of your tools that you're using, you want to profile the data set. Okay. Now, what are the kind of things you should look at when profiling such a data type? One thing you want to look at is, you know, a metric that you want to look at is the most common one is the mean. Okay, you look at the mean value, and by definition, mean just mean summing up all the values and divide by the number of values, right? This is something you really want to look at. What is the mean of these numbers? Okay. Next, also look at the median. It's very, very important. So mean and median, if this data is normally distributed, I hope you understand what is normally distributed. Okay, it means normal distributed means okay, it has that bell shape. So you also want it will probably mean that the mean and the median will probably be the same, right? But if it is not normally distributed for some reason, there are so many values that are tilted towards the lower end or towards the upper end, then you realize that your mean and your median will not be the same. So in that case, it's not normally distributed. If you're doing a statistical analysis and they say, okay, maybe the assumption is this thing has to be normally distributed, then that is already an issue. We should probably want to check it out. But if you are doing data science where the amount of data is so many, this normal distribution thing might not be so important. So I'm not going to defining median, but want to get median, you can use your tool to get the median. Other things you want to look at is the maximum, max. You want to look at the mean, okay. Then another thing too you want to look at maybe is the variance, and variance just talks about spread, how spread your data is. So that is variance, and also from variance you can get standard deviation, right? So these are the kind of things when you have a numerical data you want to look at. Okay, what is the mean? What is the median? What is the max? What's the mean? How spread is my data? What is the standard deviation? Same thing, for example, if your data type, if your variable was sales, you probably want to understand what is the mean sales already. Maybe the manager was asking you already, what is the average sales? What is our average sales? I don't need to draw a visual in order to answer that. For me to answer that question, just profiling the data set, I can already answer that business question. So what is the mean? Take note, they are not asking what is the mean for 2000 for maybe a specific year. The business question was what is our average sales? Or for example, in the case of students, I can say what is the average age of students we receive. You don't need a visual to answer that. That is why just profiling this data set makes sense. And if it's not normally distributed, then you should be thinking of median. If you miss out my previous video, which I talked about the difference, like how to watch out for outliers, then you know when to use mean or median. Now, max and mean as well. Let's say you're talking about university students, and for some reason, okay, that on average, or let's say the minimum age we can have for a year one, a student, someone just enrolled into university, maybe it's like 17, 18. Those are the ages that worst case scenario most of the time is 18, right? But there's a possibility that you can have someone that enroll into university at the age of 17 and even 16 nowadays. But if you see for some reason someone you see an age of like 10, then that is a red flag, right? So if you see age of 10, that is already a red flag. That is something you have to investigate. It's not normal for someone, yeah, at age of 10 to enroll into university. Maybe in the future that is possible, or maybe it has happened, I don't know, but already having an age of 10 means it's a red flag. Same thing for max. If you see someone of age 65, okay, that is already a red flag too, because somehow we don't expect someone at the age of 65 to be enrolling. I'm not saying that people of this age they don't go back to school. Yes, they can go back to school. I'm just saying that it's a call for concern, and you have to investigate. Now, when I say investigate, it means if you are not the like if you don't have the industry knowledge, let's say we're just called upon to analyze the data and for some reason you are not the let's say the program manager or whatever, then it's your responsibility to take this to the program manager and say, okay, I see something funny here. I've realized that there's a student with an age 10 and also another student with age 65. Is that possible? So that is how you do it in real life. You don't just sit and you take actions. You when you flag things, you have to go and ask questions. Okay. Now, so those are the kind of things you want to. That's the reason why you want to open up to do profiling, because it will give you a feeling of the data set before you even start doing any measure analysis or maybe data preparation or whatever. And also, when you flag out these things, it will also help you in data preparations, right? Now, when you have asked the question and they say, okay, this is not normal, then you probably want to you can ask them, okay, what can we do? They'll say, okay, maybe you can, delete or you keep it or whatever. You must always ask the data owner, what can we do with such flag data points? Okay, so these are just some of the metrics you can actually look out for when you're doing profiling of a numerical data set or numerical data point. You can also look at the distribution, right? So sometimes some of these tools, they will also give you distribution. I mentioned normal distribution for some reason. For you can have something like this, so it looks normal. So your mean is here. So this is your average. Sometimes if it's normal distribution, they will expect the median to be there as well, stuff like that. Or maybe it can be left skewed, so you can have something like this, or you can have something like this, right? So these are all distribution that you want to look out for, depending on the context, depending on the data. Any of this can be right. For example, if you expect that majority of your students will probably be around the age, let's say from university students, okay, I'll just give an example, the age of, let's say, 18 and 25, then this is what you usually expect. So you know that very few students will fall in this area and very few students will fall in this area, then it makes sense. um but what if you look at the distribution of the data point, you see something like this, where instead your age 18 is somewhere here and your age 25 is somewhere here, which shows that majority of your students that they have ages below 18, then there's a question mark. That is why looking at the distribution really, really makes sense. Okay, very, very important. So depending on the use case, it can be fine. Um, Maybe you have another data set that deals with sales of an item, and the fact that you have, let's say, you are selling something, and majority of the people will buy because they are not rich, because maybe there are just few rich people in the society or something. So majority, very few will buy here and majority so it just depends on the data set, and you need to understand the context and what is possible, what is not possible. That is why your distribution will help you to um, flag wrong items or wrong data points. Now the other type is, I said text. You could say, so two text, which can you can just people just I can say categorical variables. Uh, for categorical variables, in an example can be something like gender, right? Gender, there is male, there is female. I know with in the society nowadays there are other possibilities, but let's just keep it simple, right? Let's say male and female. Now, with such a data point, there are just in fact, there's just one thing I can even think of, one metric or one metric you can think of, which is just probably frequency. Okay, so if you have a data set that records the gender of the individuals, then you might want to look at the frequency, just at level of profiling. How many of my records have male as their gender? So maybe you look at frequency. So maybe it was, maybe for example, 18 and maybe 10. This is just an example. And some tools will even help you to just do a bar plot. They can do a bar plot for you. So this is the male, male is 18, and female is 10, right? So that is something you really want to watch out for. So for categorical variables, you are kind of limited with just this, you know, looking at frequency, how frequent each data value, what is the frequency of each data value. So basically, this is what you should watch out for when profiling data and how this is important. You need to understand the data points, the type of data points, and what you can actually investigate. So it will not make sense for you to have a categorical variable and you're talking about mean, max, mean. No, it doesn't. It won't make sense. Another thing to watch out for is some softwares behind the scene. The record, they can say male is one, so male is one. Why female is two. Okay. Now you need to be careful because if you just import your data into a tool, most of the time tools try to they try to just look at the observe the first 10 or first 100 data points, and they try to assume the data type. So if your software or the data was given to you as one and two, which represents one stands for male, two stands for female, your software is going to see this as numerical variable, a numerical data point. And you will now see your software will try to for gender, you'll be telling you stuff like max, mean, median, you know. And if you go ahead and you start reporting that the max age is two, for example, the max gender is one, the mean gender is two, the median gender is this, you are totally wrong. Okay. So it's your responsibility to investigate each data point and see, okay, did my software actually did my software detect the right data point? So for this case, for some software, they will not read it well. They will say this gender is a numerical variable. That is why you have to really convert and say, no, the gender variable is a categorical variable. It's a categorical variable, and now the software will be able to, instead of giving you max, median, mean, it will focus on frequency. So these are some of the things you need to watch out for when you're doing data profiling. Yes, tools nowadays are so smart to detect data types, but it's your responsibility to make sure that when you have a data set with variable 1, variable 2, variable 3, variable 4, investigate. Not just Don't just look at the results of profiling, because even like, I think, for example, Power BI, when you import Power BI, already profiles the data set for you. And also, if you use Python or R, for example, they have packages that they can profile. So yeah, they will start before they do any profiling. What the software does is, or what the tool is doing is, it will first of all try to detect which are the data types. And if it gets the data type wrong, the profiling that you're going to receive will not make any sense. So it's your responsibility to make sure that the software has actually detected the right data type. If not, make sure you convert so that the software can actually do the right profiling. So that is why you don't just have to rely on the output of softwares or tools. You need to understand what is happening behind the scene. You should not be in a rush to just say, okay, I've imported my data set and the tool has done the job and it's profiling. I just start reporting it. Ask yourself, what you are reporting, does it make sense in the context? I just gave you an example of this, right? The software might have wrongly detected that this one and two is categorical and read it as a numerical. It will start just spilling out max, median, mean, and you're there in front of your stakeholders saying that the maximum gender is one, the median gender is two. No. So in this case, you really need to understand that you need to investigate and make sure that the software has detected the right data type. So to those of you that are doing the challenge, this is something I want you to watch out for when doing your profiling. Okay, it is very, very important you do the profiling. Take your time, even when you're doing in a company, when they give you a project, it takes time. Okay, you have to take your time and report each phase of the project, because When you report each phase of the project, it's an opportunity for them to correct you, or if you have made something wrong, then the data owners will tell you, no, 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 in the business context, this doesn't make sense. So take your time, do the data profiling, investigate each data point, and make sure that your tool has actually detected the right thing. Then make a report of the profiling. So profile each data point. Normally, you cannot profile all the, yes, you can profile all the data points, but when you're doing reporting, you have to now, it's your responsibility based on the business questions to select the data points you want to present. If the project is talking about finances, it's talking about profit, it's talking about sales, it's talking about categories of this, that. From the business question, go to your data set and look for the data points that you think will help you to answer that business question. Those are the data points you want to focus on when presenting your profiling phase. Okay. Then obviously, when you do your profiling well, it's also going to help you with data preparation. With data preparation too, some of it I didn't really mention. It might also tell you the number of missing values. Missing values are not good, so you must do something about missing values. Imagine that you have a data point of, like, let's just say, keep it very simple, 10, 10 data points, and 8 of them are missing. There is nothing you can do with two data points. Two, it will not make sense for you to analyze. So you have to report this and ask, what am I supposed to do? Same thing, even if it's categorical, something, okay, the frequency. Another thing you have to watch out for is also missing values, right? There is something you have to do with the missing values. It's either you can, look for the mean, the median, or you remove them or whatever. But before you take any action, always talk with the data owners or the business owners, because they are the ones that they do understand the data set. They do understand why certain things might have happened. Okay, I want to wish you the best for the active members, also for the passive members. I hope this was helpful. If you do have any questions, please leave them in the group chat. Thank you and have a nice weekend.